Good.
Okay, so we're going to start on our chapter problem. Our chapter problem is car license plates and the law. Does anybody want to read? Thank you.
Many drivers have learned that speed limit laws are not strictly enforced, and enforcement seems to vary from state to state. Nobody is ticketed for going 3 miles over the speed limit. Some police seem to operate within the rule of 9-year fine, 10-year fine.
Have you heard that before?
Yes.
Yeah.
In practice, speed limit laws are often treated more as guidelines. When the author recently purchased a new car, he was surprised when the dealer told him that he would be given 2 license plates, but only the rear license plate would be installed. The salesman said that the state law requires license plate on the front and the rear of the car, but police don't bother to ticket drivers with only rear license plates. Are the license plate laws enforced as laws, or are they treated as guidelines? Is adherence to the law different in different states? To help answer these questions, the author collected the sample data shown in Table 9-1. The cars included in Table 9-1 are non-commercial.
Okay, guys. All right, so we're going to need this table, and this time we're working with 2 proportions. Thank you very much. 2 proportions instead of 1. Okay, so this is 9.1. Today I'm going to do 9.1 and 9.3. The thing to remember about 9.1 is that everything is independent. When we get to 9.3, everything's going to be dependent. Okay, we're dealing with 2 samples this time instead of 1. The 2 samples that we're dealing with are what? Cars with rear license plate rear only, and what? Cars with a front and rear license plate depending on the what? State. Okay? All right, so 9.1 is about what? Proportions, and that's going to, remember, independent. 9.3 is what? I think it's about means, and it's going to be what? Dependent. Okay? All right. Let's see. So here's our table. Let's start with establishing our variables, and let's see what we can establish here. Okay, so as you can see, the table is here, and we're going to have to establish our variables. Let's see what variables we're going to need here. Let's see. I think we're going to need Connecticut. We're going to call that P1. That's rear license plate. And we're going to need what? The total. Well, let me check for sure if that's what they're doing. Analysis. The portions of Connecticut illegal cars with rear license plates only is 200. Okay. Where is our claim? Does anybody see the claim? I do not see it. Let's check to see if it's in the reading. There it is. Good. Okay, so we're testing the claim that Connecticut and New York have the same proportion of cars with rear license plates only. With rear license plates only. Okay, so what is our X going to be in this case? Our X1 is going to be 239. And our N1 is going to be what? 20, somebody help me out there, 49. Our X2 is going to be, this one's what? This is Connecticut, right? This is Connecticut. Our X2 is going to be 9. And our N is going to be, N2 is going to be 550. And this is New York, right? Okay. Suggestions for variables? P-hat? Yeah? We could do P-hat. P-hat is listed there. We're just going to list P-hat as 0.117. I'm not comfortable with that. Can somebody tell me what p-hat is? Take your calculator. Why aren't I comfortable with this answer? 664?
422,645.
Okay, so we can say P goes 4 decimal places, not what? 3, right? Okay, that's P hat 1, right? What's P hat 2? That's X of 2 over what? N of 2. So 9 over what? 550. What's P hat 2?
0.16363634.
Okay, so we're gonna call that, thank you, no. You said 0, 0, 1, 6.
3636364.
Okay, I think we got that. Is that right, guys? Yes? All right, suggestions on variables.
Alpha is 0.05.
Yeah, alpha is equal to 0.05. I think that's enough, yeah? All right, Valeria? Yeah. What's wrong? Ask your neighbor, say good morning to the person next to you and then ask them if they're okay.
Good morning.
Good morning.
Okay, check requirements, yeah?
Yes.
Check. Okay, let's make sure that we get these requirements correct. Please remember that this isn't going to be on your test, right? It's going to be on the what? Final if it's anywhere, okay? All right, so here is your requirements. What do you think the first one's going to be? This is a simple random sample, right? This is a simple random sample. Okay, so how do I know if it's a simple random sample?
Assume stated.
It is
Okay.
stated in the problem, stated in the directions, or it's assumed.
Right, very good. Stated in the problem, stated in the direction, or it was assumed. Did anybody see whether it was in the problem?
No, I think it's just assumed.
You want us to look?
No, I said I don't think it was.
No, I don't think it was either. And I think for this one in particular, it can't be because it's Connecticut and what? Their states. It might be, but we can check. What page? 414. 414.
And it
Okay, you're sure didn't read it there, right?
It continued to the next page.
Yeah, but I don't think, I read it, but I didn't see simple random sample. There's a sample.
No, it just says, which includes methods for comparing two sample proportions.
Okay, good. Okay, so we're just gonna say assumed, if that's okay with everybody? Okay, so assumed.
And he said to use a p-value method.
I'm sorry?
He said to use a p-value method.
Yeah, but you have a choice, always. Okay, so this is going to be what? Assumed. Okay, so the second one is, this is really important. Normally it would be that it's a binomial probability distribution, but what they're really concerned about is that the two studies are independent. Okay, so that's all you're going to write. You're going to say these trials are independent of each other. Okay, so that's a part of the binomial probability distribution, and that's the only one you have to write. And you don't have to defend that. Okay, that's good. Okay, so these trials are independent. Okay, so the third one is just like the condition for last time, except it's a real pain in the rear. Because you have to show that it's at least what? 5, right? So you have to go, watch this guys, you have to go N1 P, let me make sure I can get this. P what?
P hat.
P hat, but it's going to be P hat what? 1 is equal to, and then you have to go N, no, let's go like N1 Q what? Hat 1, right? And then you have to go N2, you guys get it? So you have to do all the combinations. Okay, so let's start with N1. So this is, and we have to show that that's greater than what? 5. These have to be greater than 5. Okay, so
Greater than or
N,
equal to 5.
yeah. Remember I said the different books do different things? It can either be greater than or it can be what? Greater than or equal to. Okay, so let's start with that. Let's go 2049. And what was P? We did P hat 1, right? Okay, so that's going to be 0.1166. Now what we're really doing is we're looking for what? it's really gonna be whatever X1 comes out to, because that's the number of favorable outcomes. Okay, so it should come out to somewhere around 239. Can somebody tell me what they get there?
230.
What?
I got 238.91.
Okay, 238.91. Don't worry about the rounding there because it's so far off of 5, it's ridiculous. Okay, so we're really looking at the what? I think it says that here. We're looking at the number of what? Successes. Okay, it says for each of the 2 samples, there are at least 5 what? Successes and 5 what? Failures. Okay, so so this one's going to be 2000 what? 49, and then what is our Q hat going to be? Can somebody help me that Q hat one?
1 minus P.
Yes, 1 minus P hat, and what did you get for that?
18834.
8834, that's way past 5, right? And can somebody give me a number for that?
$1,810.08.
0.08. Yeah, that's good. That's good. No. All right. Don't worry about the rounding here because it's way off of what? 5. Okay, so let's do the other 2. We need N2 what? P hat 2, yes, is greater or equal to 5, and what? N2 Q hat what? 2 is greater or equal to 5. Okay, N2 is 550. And P hat 2 is 0.0164, is greater or equal to 5. And then here I get 550. And I need somebody's help with this. What is Q hat going to be here? Say again? I don't know. Are you giving me the answer to this? 9.02? Okay, that's good. Okay. Wow, that's close. Okay, and then what did you get here for Q hat? 0.9836, yes? Is greater or equal to 5, and that should not be close. What do we get there? 540.98. Okay, all right. Questions about checking the requirements? The benefit to doing all this is that you're getting one step more than you need for what? The test. Okay, we're doing 2 proportions instead of 1. Okay? All right, so what's next? What do I have to do next? Yeah, identify the null and alternative hypothesis. Identify null and alternative hypothesis, so let's take a look at that. Okay, the null hypothesis is that, let's see our situation. Are we trying to show that they're equal? You guys remember? Let's
Yeah, they're
check.
equal, they're Connecticut and New York are equal.
Okay, great. Let's check that for sure. That what? New York have the same proportion. Okay, so what do you think our null is going to be? It's going to be P1 is equal to what? P2. That should make sense to you. Okay? And then our alternative hypothesis is going to be P1 is not equal to what? P2, because all we're testing for is equality, correct? Okay,
Is it
so what's...
P or P hat?
Oh, it's definitely P, because we're talking about what? The population proportion. What's P hat? It's a sample. It's a sample. The P is the what? Population. Okay, which one is our original claim?
No.
The null, correct. Okay, so our original claim is the null. Good. Okay, if we are choosing to perform the statistics using the p-value method, it should be very easy. Are we doing that?
Yes.
Okay, perform statistics, good. Okay, so let's take a look at performing the statistics, and I might need your help with this. We're going to go under stat, test. Okay, and you should be able to find the right one here. Let's check to see if you can find the right one. Okay, stat, test, and which one do you think you're going to need here, guys? Yeah, you're going to need the 2 proportion what? Z test. That should make sense. So let's check that. 2 proportion Z test. And we know that we're in the right place because they're asking for X1, and they're asking for N1, X2, N2, and they're asking for the what? Alternative, yes? Okay, so the way we're gonna go with that is we're gonna say two proportion Z test, and we're gonna put in each of our values. So X1 is equal to 239. N1 is equal to 2049. 2049. X2 is equal to 9. N2 is equal to, really? N2 is equal to 550. And what's our alternative hypothesis going to be? Not equal to. Is there an emergency?
Yeah,
Okay.
it's a Lambert alert.
Well, mine's gonna go off in a minute too, so. All right, I wonder why he was ahead of everybody. So I guess it wasn't you, sir. It's gonna happen when it happens. Okay, 9, 550, and then, not equal to. Okay, make sure that not equal to is shaded in. Okay. Don't get it. Okay, lots of values. Which one do we use? Yeah, definitely. P is equal to, and what do we get there? Where's P? Oh, okay, so how do I write this?
1.0.0000.
Okay, but I need to know that you know what this is, so let's do 0.190479498 times 10 to the negative 12. Okay, so since P is equal to 0.0000, Yes.
Using 7.
okay, where's it go?
Before the 9.
74798.
Let me check. 747, I do not see it, somebody help.
Yeah, it's 19047498.
0474, I still see it. Somebody-
79.
Right here, right here?
After the
After the
So it's 1.190474798.
747.
798.
79. Okay. All right, good. Okay, so since P is equal to 0.000 is less than, somebody help me out here. Yeah, I think that's our significance level. What's our
0.05.
0.05, good. So 0.05, remember that we're comparing it to our significance level. What do we do? I'm sorry, what?
You reject the one.
Yeah, we reject the null hypothesis. We reject the null hypothesis. Exactly the same thing. Everybody good? Okay, what now?
And then we have to state conclusion.
Yeah, how to do, we do that. State conclusion in simple non-technical terms.
There is sufficient evidence to warrant rejection of the claim that,
Okay,
and
so.
whatever the claim was, I don't remember what the claim was.
Okay, so the first question is, does the original claim contain a condition of equality?
Yes.
Yes. Everybody good with that? Yes? Okay, so yes is across this way. Did we reject the null hypothesis?
Yes.
Yes. So she's right. There is,
Sufficient.
okay, there is sufficient
Evidence.
evidence
To warrant
to warrant rejection
of the claim.
of the claim that, okay, and then we need to go back to the problem, right? Okay, so let's go back to the problem. Claim that, there it is, guys, Connecticut and New York, Connecticut, I now know how to spell Connecticut, and New York
Have the same proportion.
have the same proportion
Of course, which rear license plates
of cars with rear
are license plates.
license plates, and that's it?
Only.
Oh, thank you. Perfect. Perfect. Are you guys all right? Okay, so it's gonna start feeling like I'm repeating myself. It should start feeling like that already. If you understand hypothesis testing, the rest of the class is gonna be a breeze. Did everybody hear that? Because all we're gonna do is change variables and what? Do the same thing over and over again to make sure that you have it. Okay? All right. Okay, so my recommended problem that you do is this problem for, we just finished this part here. That's 9.1. So I recommend you do problem 7 on page 424 in the new book, or just choose any problem in the odd. Just one is all you have to do in the odd for you to do. Don't do any more than one because you already have too much on your plate with chapter 8. Did everybody hear that? So just do one problem on this, okay?
There's a problem, one of the discussions.
Yeah,
also a problem.
that's the next section. That's the next section. So the next section is 9.3, and this is in reference to what? Discussion 5. All right, so you have to do this one because it's worth a measly 2 points. Okay? All right, so are we ready for 9.3? Okay, so let's take a look at 9.3. Let's see, what page we on here? 443. Okay, so in 9.3 we're looking at matches of people. So for example, do husbands talk more than their wives, or do the wives talk more than their husbands? That is going to be what? Dependent on each other. Do you guys get that? Okay, so what else is dependent? Does a vice president height, is a vice president height taller than the president's height, or is the president what? Taller that year? Those are dependent on each other. Will somebody who's taller win the race as opposed to somebody who's what? Shorter. Those are dependent as opposed to what? Being independent. Okay, so now we're going to look at two proportions, and this time we're going to look at proportions that are dependent as opposed to what? Independent. Okay. All right, so of course there's a whole new set of what? Requirements and a whole new set of what? Variables. The thing that you should know, and this is really bad what he does here, he puts the what? This is number 2. I have no idea why he put that. Do not put this as number 2, put it as number what? 1. Is it a simple random sample? And then you say the sample, the data points are what? Dependent as opposed to what? Independent, and then you're going to what? Talk about n being greater than 30 and them being normally distributed. Do you guys get that? Okay, so those are going to be the same requirements, except these two should be what? Switched. Okay. Since they're dependent, we're going to take the difference of the two ideas. So we have a whole new set of what? Variables, same idea. Okay, if you're comfortable with the p-value method, we're going to stay with that. The problem that we're going to try here is this problem right here. Okay? And I'll go ahead and read it to you. How am I doing on time? Great. Let me erase this and let's look at, where's the eraser? Let's look at that. Does anybody want to read that? Well, anybody besides Ariana want to read that while I erase the board?
Here we consider one aspect of how we treat women and men differently based on their ages. Data set 14, Oscar winner age. In Appendix B lists ages of actresses when they won Oscars in the category of Best Actress, along with the ages of actors when they won Oscars in the category of Best Actor. The ages are matched according to the year that the awards were presented. Table 9 includes a small, random selection of the available data so we can better illustrate the procedures of this section. Use the sample data in Table 9 with a .05 significance level to test the claim that for the population of ages of best actresses and best actors, the differences have a mean less than 0, indicating that best actresses are generally younger than best actors.
Does that sound right? That an actor is going to get a award? It's going to be can be older. People like Sean Connery and yeah, most actresses who get awards have to be what? Young things. Except I don't know if you guys know Jessica Tandy. She got a award. She was 80. She did Driving Miss Daisy. Has anybody heard? Yeah, that was fantastic. She got an Oscar for her movie Driving Miss Daisy, which is wonderful. Okay, so we're going to be looking at differences this time, and we're going to be looking at mean differences. And all we're going to look at is 5 sets. So our end value is going to be what? 5 sets. Remember that these are dependent as opposed to being what? Independent. Okay, so the first thing we're going to do is establish our variables. Our variables are unique again. Okay, and our end value is 5. There's another value that you know. What other variable do you know in this that she just read? Yeah, the significance level. She read that off. Thank you, Adina. The significance level is 0.05. The rest of it is sort of hard. So let's take a look at the rest of it. All right, so what you have to do is take the difference of the two, and it looks like they subtracted actresses minus what? Actors in order to get this what? Difference. And then you have to take the mean difference. Okay, so let's look at this and let me show you what the variables look like. Let me see if I can find what the variable, okay. All right, so this is the individual differences, right? And this is the mean difference. That means you add up the differences and get the what? Get and divide by whatever number. So this is the mean difference of the sample, and this is the mean difference of the what? Population. There's a standard deviation, and then your variables n. Okay, which you know already. And remember that n is not all of them; it's the pairs. Okay, so let's take a look at the individual differences first. Okay, and there are the individual differences right there. So let me see if we can do this using our calculator because it'll be easier. Okay, so I'm going to use my calculator for this, and let me see if I can find that table. Sort of fits. Any suggestions? Make the calculator smaller. Oh, why did I get rid of that?
No, just scroll over actresses.
Okay, we'll just scroll over. Okay, let's clear. Let's clear, and we're just going to scroll over a little bit here. Actresses. Okay, let's go under Stat. Let's go under Edit, and I'm going to clear these. Okay, and let's put in the what is this? The actresses is the first one?
Yeah.
Okay, let's put in the actresses first. Okay,
You just gotta scroll over, there's one more set.
I thought there was only 5. There's 5, right?
Yep.
Okay, and then the actors? Okay, so there's the actors and the what? Actresses. Now watch what I do here. Ask your neighbor if they're okay. Everybody good?
Yeah.
Okay, now watch what I do here. I'm going to cursor up to L3. Make sure that it's highlighted. If you miss that, you're going to miss the whole thing. All right, whose head went down? Somebody's head went down. Watch what I do again. I'm going to cursor up so L3 is shaded in. Okay, now I'm going to go L1, that second L1. See this says L1 here? Minus L2. Okay, that means subtract the two what? 2 values. And then I'm going to push enter on that. And that should give you their differences. Isn't that cool?
Yeah.
Yeah, very, very nice. Okay? Okay, so that's how you get your differences. You might want to write a note on that because you're going to need to column L3 for your, to perform your statistics. Okay, now I'm going to go ahead and perform the statistics, and we're going to go backwards. Did everybody hear that? We're going to go backwards. Okay, so here's how you perform the statistics. Did you have a question, Abby?
No, it's okay.
Okay, so let's go ahead and perform the statistics. I'm going to go stat, I'm going to go test, and then I'm going to do a t-test on this. Okay, I'm doing a t-test on this. Okay, and I'm going to do the t-test on which column? L3, the differences of them. Okay, so let's do the t-test. And then we're going to do it on what? L3. So I'm just going to use my data that's in what? L3. Okay, so I'm going to go down here. What do you think my null hypothesis is going to be? What were we trying to show? Let's go back to the textbook.
That the difference was less than 0.
Is less than 0. Okay, so what's my null hypothesis going to be?
H power equals to 0.
Okay, good, that's close. Okay, so identify null and alternative hypothesis. Okay, so my H naught is going to be the population mean differences is equal to 0. And she read that to us earlier, okay? And my H1 is going to be my population differences is, I can't remember what she said, less than what? 0. Less than 0. See right here it says what? Less than 0?
Mm-hmm.
Okay, and so we're indicating that actresses are what? Generally younger than what? Actors. So this is going to be my original what? Claim. Good. Excellent. You guys are getting this. This is great. Okay, so we're going to do a t-test on this. So let's go ahead and do the t-test. So under the null hypothesis, what am I going to put?
0.
Good. 0. Good. 0. We're going to take this from list what? 3. Because we put the differences in list what? 3. We're going to say that our alternative hypothesis is what? Strictly what? Less than, and then we're going to what? Calculate. Okay, so
Frequency change?
no, never change the frequency. If you change the frequency, you're going to run into a problem with your calculator, and you're going to wonder what happened. Okay. Okay, so let's perform statistics. What method are we using here?
P-value.
Did I state that in the last one? Oh, bad teacher. Bad teacher. Okay, so I lost some points in the last one. Did everybody hear that?
Yeah.
Okay, so you need to what? State what method you're using always. All right, let me say that again. I lost some points in the last one because I didn't state what method I was using. Okay, so stat, test. I'm doing a what? T-test. Okay, and then what did I put in? I just did use the what? Data? We've done this before, right? Okay, great. Data, our mu naught is going to be equal to 0. We took it from list 3. Alternative hypothesis is less than. And we're going to what? Calculate. Okay, let's see what happens. All right. Ooh, that's interesting. Okay, so what is P equal to? So P, did you guys get that?
Yeah.
Okay. So P is equal to 0.0972799,244, yes? Let me make sure that he agrees with me, or us.
You may want to make that bigger.
Did he use the, oh, there it is. So he agrees with me, good. Okay, so let's go back to the original problem. Okay, so what can I say here?
Since
Since P 7, 3, good.
Which is
Greater than 0.05. We failed to reject what? The null hypothesis. Wow, guys, you guys are great. We failed to reject the null hypothesis. Okay, now, the good part about this is that now we can easily do our variables. So let's go back and do our variables now. Okay, what was the mean sample mean on our variables? It's going to be x bar is equal to what? Negative 10.2. And our standard deviation, you guys see what I'm doing? I'm doing the problem backwards. Okay, our standard deviation is 14.65264481. And how many of those do I need? I just need what? 4 of those. Feel free to write them all. Did everybody hear that? Feel free to write all of those.
But 14.65 would be acceptable? Like for that,
It's
so
supposed to
we
be 1 decimal place more than, well, how many decimal points did we have for this? No,
Two.
so it would be,
14.16?
it would be 14.17. Don't take that chance.
Okay, just
All
write
right,
it
don't
all.
take the chance, just write it all down. Okay. Because I don't want to mark it wrong for that reason. That won't be nice at all. Okay.
Gotcha.
All right. What are we missing here? Check requirements? Check requirements. Does anybody remember what the requirements are? Yeah, this is a simple random sample. This is a simple random sample. Okay, what do you think? Wait, we have to defend that.
Let's assume.
We have to defend that. Don't forget to do that, Eddie, okay? Small random selection. So this is assumed. Okay, I heard the trials are what? The trials are dependent, right? Dependent. Now, that's not what they say here, but I will accept that. They say the sample data are what? Dependent. Feel free to say the trials are what? Dependent. As long as you know that dependence is happening, I'm going to be very, very happy. Okay. And then the last one is that n must be greater than 30 or the population must be normally what? Distributed. Population is normally distributed. Okay, so is n greater than 30 here? No, n is equal to 5 is not greater than what? 30. So normally what? Distributed, right? And I have to show that that's true. Does it say that it's normally distributed? Did you read that, Adina? I don't think so. So what are we going to put as our
It's not normally
assumed?
assumed.
Remember, there's 3 conditions for normally distributed. What are they? Stated in problem, stated in the directions, or what? Assumed. Okay, we have 1 step left. What's the last step? State the conclusion. So let's look at that. State conclusion in simple, non-technical terms. Conclusion in simple, non-technical terms. Okay, and how do we do that? Go back to the what? The formula sheet, yes? Okay, does our original claim contain a condition of equality?
No.
No, very good. So we're going to go down here. Did we reject the null hypothesis?
No.
No, we failed to reject. Have we used this one yet?
Yes.
We've used this one? Okay, good. There is not sufficient evidence to support support the claim that, and I have no idea, so let's go back and look.
Actress, it's like actresses are younger than actors.
Yeah, something like that. Claim
The
that.
population of ages of best actors and actresses.
Oh, that's a lot to write. For that, okay, so for the population ages of best actresses and best actors, the differences have a mean
Less than 0.
less than what? 0. And you can stop where you see the what? The number. Okay? Good. Okay, so discussion 5 is about 9.3. If you have the old text, you have the answer. Did everybody hear that? I'm not sure that it's in the new text. I can send it to you though. You want me to just send it to you? I can send it to you. What? What'd you say? Yeah, I can send it to you if I can remember. Are you guys gonna, who's gonna remind me? All right. If Effie sends me an email, I'll send it out to what? Everybody, so that you have discussion 5. One less thing to have to worry about. Did everybody hear that? All right, very good today, guys. Any questions? Okay, so you're working on your project, right? You're working on your project. Remember, your test is gonna just be on chapter what? 8. Okay, have a great day.